So, example one, first off we're going to start with some basics on types of equations, some structures, and recognition of different structures. That's going to kind of be key. A lot of times when you look at an equation or something you're trying to solve, the structure of the equation determines the best route for solving. And sometimes things can be done one way or another way, but depends on what the structure is. So if we look at these two equations we have, the first one says 2x equals 8. Right? This is a typical linear equation. If I look at what's happening to x in this problem, x is being multiplied by 2. The way we solve an equation of this type is we do the inverse operation of multiplication, which is division by 2. We recognize what's happening to x, do its opposite to both sides. So 2 divided by 2 makes 1, so that makes 1x. 8 divided by 2 makes 4. X equals 4 is the correct answer, because everybody knows 2 times 4 equals 8, right? The other equation on this board today is called an exponential equation. It has all the same pieces. They both have 2, they both have x, they both have equals, they both have 8, right? Both equations have all the same pieces, but the structure of the second equation, 2 to the x power equals 8, makes it a different type of problem. I can't just divide by 2 on this to get the answer. Okay, now, there are several techniques for solving an exponential equation. This one is the easier type of equation to solve. The harder type of equation will require use of logarithms, which will be later on in this chapter, or maybe in the next chapter before we get to the harder ones. The ones we get today, that you see today, we should expect the ability to get both bases to the same number. So what I mean by that is 2 is the base being raised to the x power. Currently 8 is being raised to the first power. I want these to be the same number, not different numbers. So if I were to write 8 as 2 to some power, 2 to what power equals 8?
4.
2 times 2 is 4 times 2 is 8, so 2 to the third power. And this is just going to be 2 to the x power, right? And my goal on an exponential equation, if I can make it happen, is to get this base to be the same as that base. If I can make that happen, if the bases are exactly the same number, then the powers are exactly the same value. So once I get to this point, that 2 to something equals 2 to something, the two somethings must be equal to each other. So x equals 3, and that's solved now. Okay, that is the easiest way it can happen. Okay, let me demonstrate the same philosophy with a little bit more challenging problem. Suppose I gave you 27 to the x power equals 81. Does 27 times 27 equal 81? So I can't make this number become this number to a power, but 27 is 3 times 3 times 3, and 81 is 3 times 3 times 3 times 3. I can make them both become 3's to powers. And again, that's my goal, is I want this number to be the same as this number. It doesn't have to be necessarily the same as either one of those numbers. I can go smaller up to a power. So what I'm talking about, 27 is 3 to the third power. That's being raised to the x power. 81 is 3 to the fourth power. So I can make them both become 3's to powers. The other thing that happens when I do this type of modification is I get this structure that is this x to the m to the n power we've seen in Algebra 1 and again here in Algebra 2, that when we raise a power expression to a power, the base stays the same, we multiply the powers together, right? So 3 to the 3 to the x is 3 to the 3x power. That equals 3 to the fourth power. So again, this is the more challenging of the type of problems we're going to see in this section right now. No logarithms necessary. My task, my goal, I want these to be the same number. Simple, 3 to some power equals 3 to some power. Once I get that to happen, I know that power 1, which is 3x, equals power 2, which is 4. And if 3x equals 4, now we're back to a linear equation type. 3 is being multiplied by x. I want to get rid of the 3. I'm going to divide by 3 on both sides. And all of a sudden, x equals 4/3. If I grab my calculator, I can check my answers anytime I want to. That says 27 to the x power equals 81. So if I do 27 to the parentheses 4/3 power equals 81. Okay, we can verify that we have the correct answer. But again, if the power is fractional, make sure you put parentheses, power, and parentheses. All right? If I type in 27 caret 4 divided by 3, it's going to take 27 to the fourth power and divide that by 3, and it's ginormous. So again, tell your calculator what to do correctly. If you want to take it to the 4/3 power, the power must be encased in parentheses. All right,